In this TechCorner series, I will look at file storage for photographers, NAS, RAID, and backing up your files. With so many options out there for storing your working files and keeping backups, it can be extremely difficult to figure out which option is best for you without having an IT degree. So in this series, I will explain in plain English the differences between different storage options, advantages and disadvantages of each, and the cost-effective ways photographers and videographers can protect their content from data loss. Just to be clear, this video is intended for small photography and videography studios of between 1 to 5 creatives. I will not be covering enterprise solutions or large server solutions. In this video, I will cover different RAID options, their advantages and disadvantages. In the next video, we will look at setting up a RAID drive as well as NAS options, and in part 3, I will explore backing up your data and various backup options available out there. So let's start with the most basic ways to store your files, a hard drive. Now, regardless if you use a spinning drive or SSD, every drive will at some point fail. It is not a matter of if, but when. Typically, desktop computers and laptops come with a single drive which stores your operating system and personal files. Many of you will add a second internal drive to store your files or use an external USB drive. The issue with this is that your files are still stored on a single drive, and if that drive fails, you lose everything. So what options do we have in terms of reliability? The answer is RAID. Now, not to be confused with NAS, which we will cover in the next video. RAID stands for Redundant Array of Inexpensive Disks and is a way to combine multiple hard drives into a single physical drive. Typical RAID configurations are RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10. Depending on which RAID configuration you choose will determine the minimum number of hard drives required to make it work. Other RAID configurations do exist, but the ones I just mentioned are the most typical for home and small business use. As a side note, when setting up RAID storage, make sure all drives are of the same capacity and speed for best results, since most RAID configurations will run at the speed of the slowest drive and the capacity of the smallest drive. So let's cover RAID configurations in a bit more detail. RAID 0 requires a minimum of 2 drives and splits all files across all the drives. The advantage of RAID 0 is speed. All drives, regardless of technology, have a maximum read and write speed. If the file is split across all drives, each drive reads and writes only a portion of the file at its rated speed, so the entire file can be accessed at much higher speeds proportional to the number of drives you are using. The other advantage is size. If you purchase 5 2TB drives and set them up in RAID 0, you will have 10 terabytes of storage. Because RAID 0 combines all your drives into a single physical drive, the total storage available is the capacity of a drive multiplied by the number of drives. There is a speed limit though. The interface your RAID is using to connect to your computer will have a maximum transfer speed, so you can't just keep increasing the number of drives expecting the speed to increase forever. RAID 0 does come with a huge disadvantage. If one drive fails, you lose everything. It gets worse. As you increase the number of drives in a RAID 0, you will also increase the chances that a drive failure will occur. So what you gain in speed, you sacrifice in reliability. RAID 1 also requires a minimum of 2 drives. However, in this configuration, data is mirrored on all drives. If you have a RAID 1 with 2 drives, each drive is a mirrored copy of the other. This means if one drive were to fail, the second drive contains a full copy of all your files, so nothing is lost and you keep on working until the failed drive is replaced. RAID controllers will automatically rebuild the RAID when a replacement drive is installed, so in the case of RAID 1, when you replace the faulty drive, data will automatically be duplicated to the new drive without you needing to do anything. RAID 1 also reduces your drive capacity to that of a single drive. If you install 2 3TB drives in a RAID 1, the total capacity is still only 3 TB. RAID 5 and RAID 6 are very similar to each other, except in RAID 5 you can have one drive fail, and in RAID 6 you can have 2 drives fail without any data loss. Now, I'm not going to go into the specifics of exactly how this works at a physical level, since this video is aimed at photographers and not IT professionals. However, in a nutshell, RAID 5 and RAID 6 add parity data which is spread over all the drives. This allows any one drive in RAID 5 and any two drives in RAID 6 to fail without downtime or any data loss, regardless of how many drives you have in the array. So let's see how they compare to the previous RAID configurations. If you are setting up a RAID 5 with 5 drives, you will lose the storage capacity equivalent to 1 drive. That means if you have 5 2TB drives, your usable capacity is roughly 8 terabytes and not 10. In RAID 6, you will lose the storage capacity equivalent to 2 drives. The advantage to this is that regardless of how many drives you add to the array, you are only ever losing 1 drive worth of capacity in RAID 5 and 2 drives worth in RAID 6. So if you have a large RAID enclosure, you can keep increasing the capacity by adding additional drives and still have peace of mind that it can handle a drive failure anywhere in the array. So far, this sounds like the perfect solution. So what's the catch? The main disadvantage is that calculating parity data for each file is processor intensive. Budget RAID enclosures don't have high-end processors installed, so depending on the size of your RAID and the number of drives installed, it can affect performance, that is, the read and write speed of your array. Also, if a drive does fail and is replaced, rebuilding the array usually takes a significant amount of time, during which your entire RAID is not protected against any other drive failure. For most file applications, RAID 5 and 6 will work well, but if you do require high performance and high throughput from your RAID, these may not be the best solutions. So let's have a look at RAID 10. The name actually comes from the fact that RAID 10 is actually RAID 0 and RAID 1 combined. For a RAID 10 setup, you will need a minimum of 4 drives and you must use an even number of drives. RAID 10 will take all your drives and split them into 2 RAID 0 configurations, which are then combined as a RAID 1. The advantage of that is you get the read and write speed advantage of RAID 0 with the reliability of RAID 1 and none of the processing overheads of RAID 5 or 6. If you are looking at building a high-performance RAID with great reliability, RAID 10 is the perfect solution provided your RAID controller supports it. The clear disadvantage of RAID 10 is you will lose half your physical drive capacity. So if you were to install 6 2TB drives in a RAID 10 configuration, your working capacity would only be 6 terabytes, not 12. So as you can see, each RAID configuration has clear advantages and disadvantages, and hopefully now that you have a better understanding of how each RAID configuration works, you can make a clear, educated decision which setup is best for you. Now I'm sure by now you're probably wondering, which RAID setup do I use? Actually, I use a number of different RAID configurations. All my photos and video files, including Capture One sessions and project folders, live on a RAID 10. My documents and user files, including my Dropbox and Google Drive, live on a RAID 1. Now I do realize that both Dropbox and Google Drive can be resynced in case of data loss, but in my situation, that's how I distribute client files, so I can't afford to have any downtime. RAID 1 will keep everything running in the event of a drive failure, so there are no delays with clients getting their images. Finally, I have a RAID 5 drive for all random files I keep, like various drivers, utilities, and personal files. These are files I need access to from time to time, but I don't want them filling up my main drives. In the next video in this series, I will look at different ways of setting up a RAID drive, from internal to external options, and even using a NAS to store your files. As always, thanks for watching. Please comment below with any questions, and don't forget to subscribe and press the bell icon so you don't miss out on our future videos.